do we remember about absolute value to participate? Give me a hand. William.
Well, you remember the bars?
The bars. Okay, bars mean absolute value. Bars like so. What else do you remember?
The number inside the bars is however how many spaces are to 0.
However many spaces there are from 0. So what if you had a -8 in the bars? -8 is how many spaces from 0? 8. What if you had +8? 8. Distance from 0. When we were solving these equations, think back to yesterday. How many answers did we have?
30. 2.
How many answers did we have?
Oh, 2.
2. No. 2. Okay, Taya, so what do you remember? How do we get 2 answers? You split them out, and how did you write your equations?
You have
One positive and one negative. Take out your sheet of white paper. Let me explain to you why we have white paper today. Today, I'm excited for this because this is the first year ever in Arizona, in the history of Arizona, that this objective is being taught to 9th graders.
Why?
Today, well this year, today. Here's why. It's typically taught to Algebra 2 students. But they took this standard out of Algebra 2, they moved it down to Algebra 1 because of our new Common Core State standards. So I was a little bit panicked last night as I was practicing, right? And I was looking at your copy of the book, and I was actually embarrassed about how your book presented this information. As a member of the professional math community, bless you, I was embarrassed. So, we are throwing out the book problems. You guys are writing examples on your blank sheet of paper, and we'll add them into your book. Cool? Okay, this first one, I'm going to talk you through it. We're going to do a couple with temperature checks along the way. So I want you guys to organize your own page. Go ahead, copy this problem down. We're going to do about 4 or 5 on your page. So here's your first problem. We have the absolute value of some number x is less than 12. So let's think about this conceptually. Some number x is less than 12 spaces from 0. Some number x is less than 12 spaces from 0. So can anyone think, what are some examples of numbers that are 12 within 12 spaces from 0? Give me some examples. 11. Give me another one. 10. Give me another one. Do you remember? What's a number that's less than 12 spaces from 0? 7. What else? Oh, negative numbers too. So we have 0. So we have positive numbers and we have negative numbers. The trick, guys, whenever you have an absolute value inequality, is to get yourself a number line. So go ahead, draw a number line underneath your problem. Visualizing these problems is going to be your key to success here. So now 12 seems to be our threshold. So let's get positive 12 on your number line, and let's get negative 12 on your number line. So can I be 12?
No.
No, so we're going to be open circle on 12. Open circle on 12. Now, which numbers have an absolute value less than? To the right or to the left?
To the left.
You guys gave me examples, they were to the left. But now, Destiny said negative 8. Negative 8, the absolute value, is less than 12. Could I have an absolute value of negative 12 and be less than 12?
No.
No. So I'm going to be open on 12, and I'm going to go to the right. So all the numbers in the middle have an absolute value that is less than 12. Once we get our number line, okay, OMG, check this. Get your split in there. We're going to split this up just like we did yesterday, and we're going to write out 2 inequalities. Okay? I'm going to model this one for you, so you're writing, you're thinking about the signs. So my first one is going to focus on negative 12. I want all numbers x. I want all numbers x. Since I'm shading to the right, that are greater than negative 12. The first half of this. I want all numbers x greater than negative 12. But then take a look over here. I want all numbers x that are smaller than 12, less than 12. Think back to your warm-up problem. This overlaps this shading. So is this an and or an or?
And.
This is an and. So yesterday, we had x equals, but today, we have two inequalities. So here would be your answer. You have two inequalities, and our variable x is by itself, it's isolated. Any questions about this so far? Okay, so what did we do first? We saw our problem, and then what? Number line. You gotta get that number line. And then we broke each piece of the number line down. Cool? All right, we're gonna do one more on your paper. One more on your paper. Here's your next problem. This one's gonna be a little bit different. So before you start your number line, let's think about it out loud together. Some number x has an absolute value that is greater than or equal to 3. So we're thinking in our head, what numbers for x have an absolute value bigger than or equal to 3? So let's brainstorm some numbers. What types of numbers have an absolute value bigger than 3? Yeah.
Bigger than or?
Bigger than, could you equal? Yeah, so we could be 3. What else could we be? Yeah. -4. What's the absolute value of -4? +4 is 4 greater than 3? What else can we be? Yeah? -3. Okay, could I be -3? Absolute value of -3 is 3 greater than or equal to 3? Yeah, absolutely. What else can we be? 5. Why can we be 5? Why can we be 5? Matthew,
Because it's greater than 3.
because it's greater than 3. What's the absolute value of 5?
5.
5.
5 is 5 spaces from 0. What else could we be? Come on, shout them out.
8.
We could be a lot of numbers, right? We could be a lot of numbers. Could I be 100?
Yeah.
Yeah? Could I be -100?
Yeah.
Beautiful. So here's how I decide which way to shade on your number line. So your threshold is -3 and 3. Can we be 3 and -3? Did those make our list? They sure did. So close circle here. Close circle on 3. Now, which way are we shading? Where are the numbers in our list? Are they in the middle or are they on the outsides?
Outside.
Outsides. Our numbers, -4 would be here. -100 would be here. 3, 4, 100 are this way. So remember, you are shading where your solutions are. So give me some arrows over. Give me some arrows over. How's this problem different than last problem?
It's an or.
It's an or. How do you know it's an or? Because they go shaded different ways, right? So now that we have our number line, we have to get our absolute value split. This part is where it gets tricky. This part is why I don't like your book. They try to put rules on this, and I think the rules are going to confuse your kid brain even more. So let's start with our variable x. I have my -3. Which way does our inequality go? Anyone want to take a guess?
Less.
Yeah, so Ariane's pointing this way. So what symbol would that be? Less than. Can I be 3, -3? So less than or equal to. You got it, girl. Let's take a look at the next side. We have some variable x. Got our number 3. Some variable x, some number 3. I already heard from you. Someone I haven't heard from. Someone else push play. Sorry, you're on pause. Someone else push play. Caitlin, which way are you going? Greater than or equal to. So are we done?
Yes.
Do we?
No.
Oh, we have to put an or sign in the middle. Good. So now, do I have two inequalities with x isolated?
Yes.
Yeah? So you're done. This next one, you're going to do on whiteboards. This next one, you're going to do on whiteboards. So transition to your board in 5. You have your board out in 4. You got your board in 3. You have a board in 2. It's not so bad, is it? No? It is weird. Easy to hear? Yeah? Okay.
The other one was easy.
Okay. So for this next one, different problem. I want to see all the parts. I want to see your number line. I want to see your number line and your two inequalities. My goodness, work together on this. You guys are going to have silent temperature checks coming up. You're not ready by yourself. Use each other. Here you go. The absolute value of some number x is less than 5. See how far you guys can get. Use each other. I'm walking around the room to help. I think you guys can get it. Okay. So your boards are a little bit different. So let's brainstorm it. What numbers have an absolute value less than 5? Name some. Write it down. Write it down. 4, 3, 2. Okay, so now let's look at the other side. What numbers are going to have an absolute value? Okay, so let's check it. If you plug in a negative 6 right here, what's the absolute value of negative 6? 6 is the absolute value of 6. What numbers would you list? Yeah? Can't be bigger than 5. So yours is perfect. So now, get your split and get me your 2 equations. Do you see how that makes sense? No? Okay, so let's back it up. Do you agree that 4, 3, and 2 have an absolute value less than 5? Okay, negative 1, absolute value is 1. Is 1 less than 5? Yes. Negative 2. Is negative 2 absolute value is that less than 5? Okay, so now where are these numbers on the number line? In between. So since our solutions are in between, Caitlin, you gotta shade it this way, friend. Okay, we're shading the numbers that make it true. This way makes them false. So this is what type of problem it is. An and problem. You got your and in there? Oh, how you doing, Briasha? Okay, what numbers have an absolute value that are less than 5? Name some. 4, 3, 2. Okay, write it down. 4, 3, 2, 1. Yeah, you did that. No, you shaded this way.
I don't think I can, since it's like less than 5, and like
Okay, so if you have negative 6, what is the absolute value of negative 6? 6. Is 6 less than 5? No. So negative 6 isn't right, that's why you shaded it this way. Okay, cool. Some of you have a number line. Let's flip boards around. Let's check number lines. Let's check number lines. Board middle people, boards up. Hold on. Hold on. All right. Hold up a 1 if you shade it in. 1 if you shade it in. 1 if you shade it in. Anyone shade out? You shaded it out? No, you shaded it in? Yes, okay. So your number line, your 2 thresholds were negative 5 and 5. We were shading in. You guys got this far. Someone talk me through the first step. Brave volunteer. Do you remember that hand? Awesome. Talk me through this first one.
You have to put x is less than.
You shaded this away.
That has to be.
No, that's okay. Do we want the numbers bigger than negative 5 or smaller than negative 5?
Yeah.
Okay, so let's go through that. We got negative 3 right here. We have negative 6. Which number is smaller? Negative 3. So I want x is less than would be greater than. X is greater than, can I be 5? Negative 5?
no.
No. So greater than negative 5. And or an or? And. Someone else. Thanks, Shamir. Brave volunteer, help me out with my other side. What's the other side? Yes?
X.
Uh-huh.
Less than 5.
Dude, that was awesome. Double that. and we're going to build it up a notch. We're going to take this and build it up a notch. We're going to take this and build it up a notch. Take back out your piece of paper. Yes, excuse me. Confess later.
We ain't no church either.
Okay, you're transitioning your paper in 5-4. You're copying down the next problem in 3. You have the next problem copied down your paper in 2. You're rocking and rolling right now. This problem is different because instead of just having a variable in our absolute value brackets, we made it a little bit bigger. Now we've added a 7. Cool? Your approach to this problem is the exact same. I'm going to model this one for you. You guys are going to have problems 2 and 3 to work out together. So hang tight, mumble to yourself if you're 1 step ahead of me. Cool? So to start this problem, we're thinking, I want all the numbers that have an absolute value greater than 21. So I'm thinking, what numbers have an absolute value bigger than 21? I'm going to list them. Well, I could have 22, right? The absolute value of 22 is bigger than 21. I could have 100. What about my other side? I could have an absolute value of negative 22. Absolute value of negative 22 is 22. That is bigger than 21. I could have negative 100. So I'm thinking of examples to help me with my shading. Now, on your paper, give yourself a number line. On your paper, give yourself a number line. Our threshold is that 21 mark. So I have a negative 21 and a positive 21. So now we're thinking, which way am I shading? I'm shading towards my solutions. I'm shading towards my solutions. So if 22 is one of my solutions, I gotta shade that direction. So I'm going to the right, and I'm thinking, can I be 21? No. So we're open. Shading to the right. So now I'm thinking, which way am I shading if I want negative 22 and negative 100? Open circle on negative 21, can't be that. On the left. So this is in 4 problems. This is an or problem question.
I thought you had to divide 7.
We're going to get there in 1 second. So first thing in, we're still focused on our number line. I want some absolute value bigger than 21. Now we're going to split, and the 7 is going to come into play. So give me your split. This is still the same that we've been doing before. So now my absolute value brackets have 7x. But now I want the numbers that are less than, because I'm going this way, less than negative 21. So my first equation, 7x is less than negative 21. That's the first half of your split. Second half of your split, 7x. I want to go to the right, bigger, greater. So 7x is greater than 21. Here's your split. Now, guys, this is just steps 1 through 4 in Unit 3. Can you solve these inequalities? Yeah, absolutely. So give me your lines coming down. We're going to bounce around the room for these, and I am to Judy. Judy, what would you do first with the problem on the left? Divided by 7. Perfect. Negative 21 divided by 7? Negative 3. Talk to me about this sign, Ariane. Keep it, flip it. Flip it. Okay, so why do we flip it? Oh, our answer is negative, but what do we divide by? Positive. And when do we flip? When you divide by a negative. So here we're not going to flip it. We're going to keep it. You got it. Hey, Briesha, what am I going to do over here? Divide by 7. Beautiful. 21 divided by 7? Positive 3. Talk to me about the sign, Chelsea.
You keep it because you didn't divide by a negative.
Good. You got it. So now we have 2 answers, just like yesterday's absolute value. Let's check it. My solution, so put your pencils down, get your eyeballs up. So one part of my solution, x is less than negative 3. Hey, Kimberly, give me a number that's less than negative 3. Any number you want, your favorite number, less than negative 3.
Is negative 2?
negative 3 on the formula. Less than would be which one?
-6.
Great, beautiful, -6. Hey, Kimberly, what is 7 times -6? 7 times 6, Harley, help us out. Isn't it like 42? Do we agree with that?
Yes.
Positive or negative? Negative. So back to Kimberly. -6 times 7 is -42. 42. Perfect. Absolute value brackets. What's the absolute value of -42? 42. Is 42 greater than 21? Yeah, so this one's right, for sure. Let's check another one. We're up to Shane. Shane, pick a number that fills this one. X is bigger than 3. What do you got? 7. Great, that is a great number, Shane. Shane, if you plug in 7, what do we end up with?
49.
Not square root. Absolute value of 49?
49.
49, is that greater than 21?
Yes.
So are we right all around? Yeah. What word is going to go in between them? Or. So x is less than -3, or x is greater than 3. Question?
Is it okay if I graph that?
That would be awesome if you graph that as well. You didn't have to.
I don't know.
Okay, before we do the next problem, today's goal is to solve absolute value inequalities. It's overwhelming, I know. That's this. So I want you to think in your head. Can you solve this problem all the way through? Get me your number line, get me your split, solve your split. Can you do that? Upside down, backwards, in a cave with your eyes shut.
Yes.
You're a 4. Okay? You're quiet. You're a 2. You're a 2. If you can get here, you can get that number line, but we can't get our split. We're having trouble with our split. We need some work here. Okay? We're a 1. We're a 1 if getting this number line is where the challenge is. So can you hold up where you are? Can you rate yourself for me? Rate yourself for me. What do you think?
5?
Sure, if you're super, can do this also underwater while holding your breath. Okay, so now here's what I want you to think. So I see your number. I need you to think, what else do you need? So we're going to do more examples, so that's not it. What piece of the puzzle are you missing? That's what I want you to think about. So what part of this is confusing to you? Think about that. Tell your neighbor where you get confused. Ready, go? Where you get confused. Where you get confused.